I came to Puppet Labs as a sysadmin, did some professional services, and then moved into product. So I'm going to talk a little bit about my story as a sysadmin, but this talk is mainly just an introduction to what we do, what our space is like, and kind of setting up talks for the rest of the day. Just a quick housekeeping note on that. We're moving right from my talk into another talk by Jason from Salesforce, and then we'll have a break. So after I'm finished, please stick around for the next talk before you get up and refresh your coffee. So let's make sure that throughout the day you're thanking our sponsors. So Rocket Space is making it possible for us all to sit here and watch some talks today. SolidFire and Parasoft are also sponsoring and making this possible so that you can come here and partake in a day of Puppet. So be sure to thank them very much. We also wouldn't be here today without our speakers from the community and from Puppet Labs, so please make sure that when each speaker's up, give them a warm welcome. And thank you very much personally to each of you. Give me 1 second here. Okay. So I'm only going to do this part once, and I think I can see enough of you to get the hands, but I'm going to do a little bit of the survey. I wanted to record things, but I made it difficult for myself to write on paper with all of this machinery up here. But I wanted to get a sense of who in the audience would identify as a sysadmin or an operations person, by show of hands. Thank you. And conversely, how many of you would come from the engineering world or the development world? Okay, thanks. Well, we've got a pretty nice split here. That's nice to see. Okay. And then how many of you, and this is whether you're developing against this platform or managing this platform, how many of you are working on Unix, Linux systems? Thank you. And conversely, Windows or Mac? Okay, no Mac, C, and C, we're counting that differently. Okay, last series. So now I'm curious about what automation tools you're using. And so first off, I'd like to see a show of hands of whether you're using any automation, whether that's scripts you wrote or tools you brought off the shelf. It doesn't have to be Puppet. Just curious who's doing automation. Okay, not surprising. But can you keep your hand up if you're doing automation? Because I'm curious if you are, instead of doing automation with a script you've written, if you've done automation with a tool off the shelf. Okay, and then how many of those tools off the shelf are Puppet or Puppet Enterprise? Okay, thank you. Okay, that concludes my interactive portion of the talk. So the questions at the end. Okay, so let's talk about being in operations. And this is something that, like I said, I come from operations. I did operations at Penn State University, where I worked for their central academic unit on a bunch of different systems with the faculty and staff. And I live this life of being the sad sysadmin. I can't quite see, but he's under a bridge. And I guess the life of a sysadmin is one, at least as I recall, and hopefully this resonates with you, as being one of constant interrupts. I was responsible for servers for a bunch of different services, but also desktop support as well for some of the staff within the IT group that we had. And so whether I was provisioning a new service or managing Adobe Photoshop on various machines, my day was driven by the demands of people around me. I didn't really get to focus on what I was doing. I got to do my core job of systems administration in the kind of in the gaps. So constant interruption is key to our days, but I think there's been some research that I don't have a citation for here, but that if you're interrupted, you take about a half hour to get back to what you were doing. And for me, I'm a little bit worse, probably about an hour. And that's really difficult to deal with. So being a sysadmin is hard enough. You have a lot of pressure on to build a lot of infrastructure with very little training, very little time to learn, and you're doing it with constant interruption. And it's more critical than ever that we do great jobs as operations people or as engineers working with an operations team. Our CEO, Luke, has often said that there's no future with less servers. And what he means is that like clearly the internet is not going away tomorrow, and it's only getting bigger and only getting more global, and we're all getting closer and closer connected by the internet. There's a lot of servers that are responsible for giving us that connection to everyone else on the planet, and that's only going to increase, especially since servers continue to get smaller and commoditized. There's just going to be a greater quantity of them, even if each of them is doing less individual work. And there's definitely no future where those services are less important. I imagine that each of you has something where it's taken away from you, your life hurts. For me, coming to San Francisco, I love visiting the city, still know my way around it. So Google Maps is a service that I depend on day to day. It's critical to me. If that service is down, I may not make it on time to the talk today. So another side of being more critical than ever is I think a lot of companies have started to realize that it's a competitive advantage to be really great at both software engineering and operations. We noticed a trend in the 90s where a lot of companies were just outsourcing all of their IT. And there was that big push to say, okay, all of this isn't our business anymore, and it didn't matter whether it was development for the business application, to the file serving, to the mail, everybody was outsourcing that IT. And then I think really in the last decade or so, that trend is reversed. And people are doing much more IT in-house. And I'm going to talk to you in a minute about what I think that split's like. I think that's all I really wanted to say there. So IT is more critical than ever. There are more servers than ever. And in order to, if it is becoming a competitive advantage for people to do great operations and great engineering, you've got to be faster and more focused than people doing the same thing as you. And so it's not just about the technology you're bringing out, it's also about 4 criteria: your speed, your agility, your focus, and your alignment. So I'm going to go through each of those. Speed's pretty clear, like how quickly can you deploy that application, and whether that's just how quickly can you get a single update out to how quickly can I build an entire new infrastructure for a new app that we're about to launch or a new service we need to offer internally. Agility is about being able to change if it's wrong. If you are building a data center with 10,000 Spark machines and you realize, actually I need an x86, you need to be able to change course pretty quick. I doubt that happens, but hopefully you get the point. And focus, I'm told to reference Jim Collins' good to great concept of a hedgehog that does one thing amazingly well, but I have no idea what that means. Does anyone else know that quote? Great. Okay, so forget that. Focus is really about what it is that's critical for you to do to succeed at getting whatever technology you're building out the door. And the way I look at that is like at Puppet Labs, if we were to start building a mail service, that would be way away from our core. We may think that we need to build a great mail service to give you some next feature in Puppet Enterprise, but we'd be losing focus on what it is that makes Puppet Enterprise or Puppet truly useful. And alignment is very much related to focus. And alignment is, am I building something that my customers are actually going to use? I can be really, really fast about it. I can change when the technology is wrong, but if I've chosen something that everyone I'm selling to or giving to is, hates my software, hates my infrastructure, hates whatever it is I provided, doesn't matter how quickly you did it. Then it matters how quickly you can change it. So, cloud. This is changing things a bit, but it's also confusing things a little bit, because I'm not here to talk about the cloud that you'll see on commercials at home, where someone's like, oh, introducing the home cloud, where it's actually just a hard drive with a Wi-Fi adapter that lets you back up to your home network. Right? That's not cloud, that's not new, that technology's been around forever. It's just people using the term cloud to resonate with a group that doesn't really fit into our world. So there's a lot of things, even if you take away the sort of home marketing aspects of cloud, there are still a lot of relevant things for us when it comes to cloud. So one of those that's super apparent is infrastructure as a service. So Amazon, Google, Microsoft, and any other vendor, like Rackspace for instance, are offering great infrastructure that's available on demand wherever you want it, at whatever scale you want it. That's changing a lot of things. It's certainly changed my life as a sysadmin who had to deal with taking IBM blades and racking them and put a CD in and wait for that CD to boot, and then get into my Kickstart environment, then build Red Hat, then get Puppet on, then provision. Like that, all of that whole cycle goes away if I'm using a cloud provider for infrastructure as a service. And then there's also software as a service, which ends up a lot of times running on those cloud infrastructure as a service platforms to offer some discrete service. And that's changing things in the sense that it lets you be more focused as a company. I'll give you an example from Puppet Labs. We built software, pretty clearly, but we have a lot of services that we need to build software. We have mail that we need for our own company, we have file serving that we need, we have automated tests that we need to run, and so we get to make a decision as a company because of the prevalence of software as a service and infrastructure as a service. We get to figure out where we're best to specialize. For us, we have no business in mail, so we use Google Apps for our mail. For file storage, we use Box. We don't want to be managing file services for all 350 of us, so we use a service for that. But we do an amazingly large amount of testing of our software, as you hopefully have noticed, and that infrastructure is something we specialize in. We augment that with infrastructure as a service and Amazon, but primarily we run our own infrastructure on VMware for spinning up and tearing down tons and tons and tons of virtual machines every minute. So, one more thing to kind of set up our space is immutable infrastructure. In a slightly similar way to cloud, it's changing what options we have for moving quickly, for specializing in our craft. But it's changing things in a slightly different way. There's a quote here that there are no trends in IT that weren't done first by IBM in the 60s. And that's certainly true of virtualization and containers. And I think if we look a couple decades from now, everyone's going to have robots playing Jeopardy, and IBM will be proven correct again. So immutable infrastructure, and certainly Docker containers, again, not a new technology, but a new way of using that technology. Docker's figured out that it's largely about workflow and tool chain, and that it's not like the core infrastructure of LXC containers are great, but they're not as usable as they are now with a lot of the tools that are coming out. And it's still in mature space, so I think if we were to have this camp again next year, we're going to be having a very different conversation about Docker and other tools that emerge that are really about how quickly can I build infrastructure that's repeatable, that's resilient, and it's a pleasure to build and manage. Okay. So to tie this together a little more, all these characteristics that I'm talking about really do matter. It's not just hype. So one of the pieces, I guess, aspect of evidence is our DevOps survey. So we did this in 2014. It's out there now if you want to participate. But it was really a survey about how people are doing IT. And we started to correlate a bunch of different data to understand the way people are treating IT today. Does that have an impact on their bottom line as a business? And it turns out it really does. So there's some stats here, but you can go check out the full report. But these companies that are implementing certain practices, and I think there's a whole list on the report, but it's things like we're using version control, we're automating deployments, we're using CI, these kind of things that you're all aware of. It's just a matter of how much are they implemented at these certain companies. They're 2 times more likely to be profitable, 50% higher market capitalization. Essentially, they're able to outperform their competitors and build better services because remember those qualities, they're faster than their competitors in their space, they're able to change when things are wrong, they're focused on what matters to them, right? And they're able to target great software to people who want to use that software. Okay, so definitely participate in our 2015 DevOps survey. It's not clear from this slide when that closes, but I know it's coming up soon. But that's out there now. I'd really love your participation. And now I'm going to switch into talking about Puppet Labs and our technology. So judging from our poll at the beginning, I think most of you are familiar, so indulge me on a little bit of a primer here. But Puppet's really about automation. It's just automation software at its core. And it's about making rapid and repeatable change to whatever that infrastructure is. And again, we're trying to focus on those core ideas of you should be able to move very quickly with Puppet and your infrastructure, and you should have a lot of information about what your infrastructure is like. And when we talk about what you can manage with Puppet, that's a constantly expanding definition, and there's a couple of different categories that I slice that into. Certainly, one of our main benefits is that we work across a lot of different operating systems, so certainly Unix, Linux, Red Hat, but then a ton of flavors within the Unix and Linuxes especially. We're about automating different infrastructure providers as well, so whether it's just on-premise virtualization or infrastructure as service providers, We help you build infrastructure against these services to then build services on top of. And then we're increasingly getting into network and storage. You may have seen us put out a module for managing F5 devices. We have a number of partnerships with Cisco and Brocade. There's Arista and Juniper on this slide. A lot of these vendors are really trying to push automation in network devices. And I'm curious, since this is such a new field for us, how many of you are doing any automation of your network devices today? Wonderful. Okay. Great. So it definitely is a new space, judging from 4 out of, what do we have here, like a couple hundred. But it's a really interesting space for me. So when I was at Penn State, one of the services I was responsible for was Shibboleth, which is an Internet 2 software for doing federated identities between universities, was essentially how it was used. But it was, the thing that's interesting to me about that is that it was managed by somebody who was, I lovingly refer to him as a Luddite, but he was a network admin from, he's just been doing this for decades and kind of fell into managing Shibboleth and did everything manually. So he would go for every new blade chassis that we would buy and install. He would hand crimp all the wiring. He would wire it up. He'd plug it in. He'd record on pencil where all the ports were connected. And so he'd take probably a full day for every chassis if he was really attacking it. It was probably more in reality because long lunch breaks or whatever. Lovely guy, but he'd just been doing it that way forever. And through this Shibboleth project, we had to build out, I think, a dozen Red Hat machines, and they all had to synchronize their configuration for this federated identity software. There was a lot of coordination that had to occur very tightly. And so he got to a point where he realized, I can't do manual administration of all these machines anymore. Shibboleth has gotten too big at Penn State. And so I started working with this guy to automate that infrastructure with Puppet. And he wasn't going to learn Puppet. That just wasn't his thing. He didn't want to deal with that. He knew what configuration he needed to interact with. And so what I managed to build for him was a system where Puppet was building these configurations through templates, and he was able to drop onto a SAN the different configuration snippets he wanted to build in. So basically, you would say, this university has access to these particular things, and they can come in and contact and access our library system, for instance. But he got it so that he could drop all these snippets in, run a Puppet command, and Puppet would just re-trigger. It would add in that configuration, it would restart the service, it would interact with load balancers, and he was blown away. He loved it. And this is a really long story to say that was a sort of a light bulb moment for him where he started to really appreciate what automation could do and started to think about why he was spending a full day crimping wiring and plugging in a chassis and wiring that up by hand every time. He used to think that was a really fun thing to do, and nowadays it's just a chore. So I have faith that networking will be automated, even though a lot of these admins have just been doing it for so long that they don't really think about automation the same way that a lot of us do for our systems. So watch that space. Diatribe over. So the Puppet approach. We've really got 4 ways of interacting with infrastructure, and we call that define, test, enforce, and report. The idea here is that Puppet, and if you've seen this before, I apologize, but it's a super simple language where you're expressing the desired state of a thing. And this is an example of that very small atomic level. We call these resource types, and in this case, we can manage a service, and you could say, I'm managing the SSHD service. I want it to be running, and I want it to be enabled on boot. And you can just put that in there in an expressive way and manage any services that would be manipulated by initd or systemd or whatever. And just to call out on the side here, a lot of these modules that you see from the Puppet Forge contain a collection of these primitives to express the full configuration for something like SSH. So it's not just the service, it's the package, it's the file, it's probably some other configuration in addition to that. But once you have all of that infrastructure declared as atomic units in Puppet code, you can test them. And you can test them in a variety of different ways. And you may have seen all the different testing approaches from Puppet Labs. But you can, yes, this actually parses against Puppet's language, so it's valid as far as Puppet's concerned. But then you can get further on, and you can say, does everyone agree to a style for how we write our infrastructure as code? And then we have tools that can analyze that style is consistent across every code that we write, every piece of code. And then we can also test it by running unit tests or acceptance tests. But even more basically, we can run Puppet on the system that's meant to manage SSH and pass a flag that we call an OAuth, which is a simulation. You're telling Puppet, I've told you what SSH should look like. I'd like you to run on this machine and tell me what the state of SSH is now, compare it to what I told you to do, and then give me the results. And Puppet will do just that. And if you decide, okay, I've done this simulation and I know that my service is stopped and Puppet would turn my service on, it told me that through my simulation, I can tell Puppet to go into enforce mode where it'll actually start that service. And it'll tell you exactly that service was stopped, should be running, I would run this command to start it. So you can not pass the no op and just tell Puppet to enforce. In this case, we're ensuring a particular file is present, but again, any of these primitives, any combination of them, it's the same approach. And then after Puppet either does any of these things, so when Puppet simulates what it would do, or when it actually enforces a state that you want to find, it'll give you a report on that. It'll tell you what it did, what it found, what state the system was in before Puppet touched it, and then what state Puppet left it in. And sometimes that really matters because Puppet may attempt to make a change, and for some reason it may not be able to. Maybe SE Linux is enabled and it can't actually manipulate the certain config. Puppet's going to report on that as well. So I'm going to go a little bit more into how it works. As I said earlier, the resources are just a very small primitive. So in this case, we're bundling up into 3 different resources, a package, a file, and a service. Same kind of syntax. It's about declaring the state that you want. It's not about taking actions. You're never going to see in the Puppet language something that says service, blah, restart. That all happens underneath the abstraction. In this case, you just say, I want a package installed, and you can establish relationships between these things so that you can say, I know that this package needs to be installed before I can manage any of the files that that package would deploy for me. And then you can do things like this subscribe, which is kind of special. That says, hey Puppet, I really care about the relationship between this service and that file, such that when that file changes, I want my service to respond accordingly. And you can define what that means. By default, it means restart the service whenever the thing that it's subscribing to, the file in this case, whenever that file changes, the service restarts. It's a simple DSL, and you'll see this class mechanism. That's not like a programming class. It's really, you could rename that bucket and get the same effect. It's just a grouping of configuration that you can tell Puppet about in a broader sense. And it works the same way regardless of operating system platform. Obviously the details change. You might be managing the Apache HTTP daemon on Linux. You might be managing IIS on Windows, but you get the same kind of primitives, the same kind of declared state, regardless of your operating system. You just tell it what you want the state to be in. You get that same simulation, the same enforcement, the same reporting. So this little bit of an eye chart is to explain how Puppet works in its interactions. And there's a couple reasons why this is important, but let's walk through it. So the first thing that happens is, let's say this machine over here checks in. It sends what we call facts to the Puppet server. And the facts are anything ranging from what operating system is this machine running, to what memory does it have free, what memory does it have in total, to any custom thing that you can query on the system and return a key value pair. So that can be what disks I have, what network adapters I have, and I've seen people write facts for things like warranty information, where it'll just call out to a warranty service, post a serial number, and then return as a fact whether that machine is still under warranty or not. I've seen people do that for Red Hat subscription status as well. But anyway, the machine sends all of its facts to the Puppet server, and all that information about the host can be used to manipulate the configuration of that host. So if we go back a second here, you could say in here, if the machine checks in and doesn't have enough memory that I expect it to need to run .NET and IIS, you can pass through a message, or you can change the configuration to match the memory requirements that you actually have. So you send the facts up, Puppet server uses those to generate instructions for that individual machine. And the other distinction I want to make here is that Puppet never sends this code in the raw to any of your endpoints. And this code may be kind of generic. It may be something you want to use for a whole fleet of IIS servers. Puppet sends individual instructions that we call the catalog to those endpoints. And that's, again, instructions very specific to it. And it'll be things like, I was told to enforce this file, this is where I get that file from, this is the properties for its permissions, and it's kind of the details about how that file should be on this particular system. Then you go through that loop I talked about earlier, where you can either simulate what would happen if I were to enforce this catalog, or you could enforce the catalog. After either of those actions, Puppet sends a report back to the Puppet server, and that's just rinse and repeat as often as you like for any of your infrastructure. When we get all that report information back, actually each of those elements, the facts we get from the machine, the catalog that represents the configuration it was meant to enforce, and the report, which is a reflection of what Puppet took to enforce or simulate that catalog, all of that information is stored in PuppetDB, which the Puppet server interacts with. And one of the really interesting things about PuppetDB is it's got a REST API for querying all that information. Again, the facts about all your infrastructure, the configuration they're supposed to have, and the reports on what configuration they actually have. And all of that's available via REST API or via a bunch of different things from the Puppet Forge, where you could, within your Puppet code, call out to PuppetDB to get information about another host that you might use for configuration on another. It's kind of the foundation for a lot of different things we do. So I'm going to go into some of the more deep level details on some of this technology, but still keep it somewhat high level. The biggest change since the last time we spoke at this Puppet camp, or maybe a little bit before that, was the Puppet server itself. So we've kind of rebuilt it to be, it used to be that you'd run, Puppet is a Ruby-based software, so we used to run that through Ruby MRI under a passenger Apache stack in Puppet Enterprise. And in the community, that was often the stack used, or you might substitute Nginx in and run it with Unicorn, or you might use Mongrel if you really, if you like Mongrel. And so we've kind of revisited that for the next generation Puppet server, which is now available open source and is shipping in Puppet Enterprise 3.7. And this runs on the JVM. And so we run the Ruby Puppet in JRuby processes on a JVM. And I wish I had a chart here for you, but we found that it's able to respond to requests 3 times faster, and it's able to compile those individual instructions, the catalogs, 2 times faster than it was before with the previous stack on the same hardware. And it's also beyond this startup time that you get from a JVM. Once you start it up, everything is just way, way, way faster. I'm still surprised at how fast that thing can be. So that's our Puppet server. Check that out. And we also have some other technology that's sort of complementary to the Puppet server. So we have Razor, which was originally an EMC project that we brought in and worked on quite a bit. And Razor kind of sits between the Puppet server and your infrastructure. And it's really about bare metal provisioning, although it can do other things as well. But you kind of give it a sense of what infrastructure is out there by running little microkernels on all your raw hardware that's ready for work. And so in my case, it would be, Max, the network guy, would rack up that Blade chassis. He would, boot it to this microkernel on a Pixie network, and then it's available for me to look at and say, okay, I see Max just installed this new chassis that has all this hardware. I know that I want to install, certain OS on it with certain configuration. Razor is a means for kind of declaring that business rule and then letting that infrastructure, as soon as it's on the network, be provisioned and then given real work to do without a whole lot of human intervention. We also have mCollective, which is, I see that as sort of the complement to Puppet, in that it's not about enforcing a desired state continuously. It's about taking action on the infrastructure right now. It's ad hoc execution, if you will. But it does that based on all the information we have on your nodes. So you can say things to mCollective like, take every machine that is currently responding on the network that is running Red Hat with a certain memory profile, and then I want you to restart a service on those boxes, but only 10% of them at a time. You can issue that in one command, and then mCollective will query the network for things matching your facts, and then it'll do the command like service restart for 10% of that host list, and then continue iterating through. And it's kind of flexible in the sense that you can really tell it to do pretty much anything that there's an extension for, and it'll do it in the same way. All right. So Hyra is, again, another piece that sits alongside Puppet. But you saw in that Puppet code that I showed you, all the kind of details were hard-coded into our manifest. Details like, well, I guess it didn't have the version, but you could tell a package to install a particular version, but then it's sort of hard-coded in your model. And then you're kind of restricted from being able to say, here's how I want my Apache server to be installed across the entire fleet, but some of the fleet might be running a newer version of Apache than others. Hyra is the tool you use to separate the data about your infrastructure from the model of it. And so HIRA stands for hierarchy, and you can just give it a hierarchical lookup, so you can set a business rule like based on the data center or the environment you're in or some other selector that you have. You're going to filter machines on that and then pass them a particular version for a package that you want installed when they match a certain criteria. Then we have R10K. How many of you are using R10K today? Okay. I hope that'll be triple that number by the next time we speak. So if you're curious about R10K, come find me. I product manage the group running right now. But R10K it's really about deploying your Puppet modules. So Puppet modules are the collection of all that code that represents your infrastructure, and you're meant to kind of segregate it to a module does one thing really well. So a module would be responsible for the Apache web server, then you have another module that's responsible for a database, and so on. And R10K helps you represent those as a set and deploy them to the Puppet master. But where R10K really gets interesting is interacting with Git. So let's say you have an Apache module that you're really happy with, but it's got a bug in it that you'd like to fix. One way to approach it would be you fix that bug on your Puppet code base, and maybe you're writing directly on that module on your Puppet master. But what happens in the process of fixing that bug, you put a typo in, maybe you add 2 commas instead of 1 at the end of your line. Now, no machine can use that Puppet model because everything's broken. The syntax is broken. Now you've just taken down your fleet because you're trying to fix a bug that was only impacting a percentage of your fleet. R10K is meant to help you solve that by taking the mainline production Apache module, using a Git branch to make a lightweight copy of that module, and in that isolated copy, you can fix your bug, hopefully syntactically correct. Maybe you've tested that you are syntactically correct. But then R10K lets you simply say, all right, take that branch of this model and deploy it to a new segregated environment on the Puppet master. You can call it test, or it might match the branch name you've created. And that's a place where you can take a canary host, or maybe a bunch of them through mcollective, of the machines that should be running Apache that you want to apply this bug fix to, and you can say, hey, go try this different configuration in the test environment as opposed to the production one, and evaluate that change. You can go through the same cycle where Puppet simulates what it would do, then it enforces the change, and then you could say, great, my bug fix worked, I want to roll it out to the whole fleet. That's as simple as doing a git merge into your production branch and rerunning R10K. That's the gist of it anyway. And then of course there's open source Puppet. So I was talking about the Puppet server as being the thing that runs your Puppet master, but it's all built on Puppet. Puppet being the client and server software. So now available is Puppet 4. Is anybody running that yet? Puppet 4? Puppet 4? Oh, okay. Well, it's only in release candidate now, so if any of you were running it, I was going to come talk to you afterwards to see if it was in production. But check that out. There's a couple of things in Puppet 4, beyond the internal improvements that just make Puppet leaner, faster, whatever, there's new language improvements in Puppet 4. The big notable one is iteration, so you can actually take some piece of data and iterate over it, and that might be take a list of users from some data source somewhere, maybe you're querying LDAP, and then for each of those users, build out a system user for it, or add them to a group, or whatever it is, that before, it was a little more cumbersome to do it without iteration. There's a lot more than just language enhancements in Puppet 4. Another one is the all-in-one agent. So all of these things that I talked to you about, there's HIRA, which is that data store for data. You have Factor, which gathers information about your nodes. You have mcollective, which is doing remote execution on your host. And you have Puppet itself. You kind of need all those components to have a full system, but you have to bring them all in independently before. So Puppet 4 introduces all-in-one packaging, so that you could just install a Puppet agent and have all of those client-side pieces installed. And the Puppet server is a simpler way to install server-side components. So now we get to Puppet Enterprise. And Puppet Enterprise, at its core down here is all the open source components. So you would have both the server side, Puppet server, the mcollective server, HIRA on your server side, and on the client you have your mcollective, you have Factor, and you have Puppet. Puppet Enterprise also kind of pushes this idea of Puppet apps, which you may have seen if any of you were at PuppetConf last year. It's this idea that Puppet Enterprise is providing, beyond the open source componentry, a bunch of different workflow-based tools for doing things. The first that we launched was the node management, which is manifested in Razor, being able to provision infrastructure, whether it's bare metal or otherwise. It's a collection of our bunch of modules for declaring infrastructure as a service resources. So you can say, here's my AWS instance, here's my S3 bucket. And then it's also the thing that you use to assign work to nodes, our node classifier. It's a kind of a domain-specific thing, but it just says, hey, everybody install Apache at this version, yada, yada, yada. It's a tool for doing that. We also have our configuration management app, which includes the event inspector pane in the enterprise console, and a few other reporting tools that are built on top of PuppetDB, and you'll see those expand over time. And then we start moving further down across the line. This code management one, for example, includes R10K. R10K right now is an open source project that is not part of Puppet Enterprise. The next version of Puppet Enterprise will ship with a supported version of R10K, and we'll continue to build from there to give you better workflows for working with your Puppet code, for managing change to it, for testing it. All of those things that you would roll together today, you'll start to see shipping as code manager. And you'll see similar things from our other Puppet apps. So I kind of just told you a little bit about Node Manager. This is a way to say machines should do some work based on facts about themselves. It's really just a role-based system for doing that. Another part of Puppet Enterprise is the role-based access control. So you may, if you have multiple teams interacting with Puppet, you may want to segregate who can do what to which machines. That's what this is all about. And then on the reporting side, it's not just reporting about your infrastructure, but it's also reporting about our infrastructure, the Puppet Enterprise infrastructure. So one of the things that's built into the Puppet server on Puppet Enterprise is this metrics dashboard from Grafana. Actually, I think this is Graphite. But either way, it's an endpoint by which you can feed out metrics to different dashboards, and we build one by default to give you help of, in this case, how many active requests are coming into Puppet Master, how long are each of those requests taking, really informative metrics for whether it's time to scale up to multiple Puppet Masters. On the flip side, we have, as I mentioned, the event inspector, and this is about your infrastructure running Puppet to enforce configurations, and you can get information back about whether machines have dropped off and they're no longer talking to Puppet, machines that have just recently changed their configuration, which you can drill in to figure out whether that's change you meant to do, whether that's change that's happening because stuff's changing on the box, and so on. Another aspect that's a little less fits into a box is our supported content. So if you've ever been to the Puppet Forge, and I hope you have, I used to be the product manager of it, and I still have strong feelings for my Puppet Forge. It has, that's wrong, it has 3,200 pieces of content now that are largely maintained by the community. And when I started at Puppet Labs in product 3 years ago, we had less than 300, and people weren't really contributing to it. There weren't people that weren't responsible for that module contributing to it. Nowadays, I think we just crossed 1,000 actually, where we have 1,000 individual contributors who publish modules to the Puppet Forge that make up that 3,200. But what's even more interesting to me is that on average, every module on the Forge has at least 3 contributors who weren't the author. So that's people who have found that module, used it, maybe they wanted to add a different platform to it, maybe they wanted to fix a bug, whatever it is, they're contributing patches back to that source code of the module, which is then making it back as a published release to the Puppet Forge. And Puppet Labs also tries to provide some content on there. We have about 100 modules of our own, and some of those are supported with Puppet Enterprise. And that largely means that we've gone the extra mile to make sure that they're really, really reliable for all the different use cases you want to do with, for instance, F5 or the Microsoft SQL Server. We also have a bunch of different modules for Windows, for managing access control lists, interacting with PowerShell, things of that nature. And you'll see more coming for the rest of this year. And we also have the Puppet Approved program, which I'm pretty excited about. That's taking that 3,200 modules from the community and making sure that we have a selection of those that we run through our own validation. So anyone in the community can nominate a module, or we pick modules that people have highly rated from the community, and we just every week review as many as we can get through, and then check them against our own guidelines for style and tests and code completeness and quality of that code. A bunch of different qualities that you can go and do at forgeupoflabs.com/approved. And that's pretty cool. That gives you not only more confidence in the modules the communities have written, but also modules from us that are supported with Puppet Enterprise. I like it quite a bit. So I've just yammered on for about 20 minutes about all the things that are impacting our space and what Puppet Labs does. So what? I hope I painted this picture already, but if not, doing automation is critical. I think you're all here because you like automation and you already know what it provides for you. This does come from the 2014 DevOps report. People who are doing automation or using version control for code, you're able to deploy a lot more quickly. You're able to do that with less failures on either your application software or the infrastructure running it. And we just noticed a trend where companies who are doing these practices effectively are just being better companies and outperforming their competition. And here's a few of them who have kind of used a lot of these practices to outperform their competition. Getty's a big user of the Forge. I've interacted with them before. They're all in on having both their own Puppet modules, defining configuration, and contributing back to the community and using what the community's provided to make change really quickly to a lot of infrastructure that serves really nice images. Disney's pretty cool as well, especially since they acquired Pixar, which is, I always really enjoy Pixar films, and I like to think that Puppet's playing a big role in those films, at least in making all that video rendering possible. There's a lot of servers that go into rendering even a frame of one of these movies, so it's pretty cool that we can be a part of that. So, beyond being here today and talking with your peers, talking with the person next to you about Puppet, about automation, there's a few other things you can do after you leave here. So one of the things you can do that I like quite a bit is learning online. I think it was last year or the year before, we launched the learning management system, puppelabs.com/learn. So it's a free account, and then you can log in and take a bunch of courses. And these courses range from what is Puppet, how do I write my first module, all the way through to testing modules, using Hyper for data and code separation. So from beginner to intermediate to advanced courses with Puppet. And then that's extended to a bunch of other education offerings that we do. So we also have instructor-led courses where people like my former self in professional services would go on site or at a public venue and teach you from the fundamentals of Puppet all the way to advanced concepts of using Puppet for some crazy new thing you're working on. And we also now do that virtually. So if you don't want to bring a consultant on site or you can't travel or whatever, we can just set up a virtual training with you and your peers where our instructor will see your screen, give you advice on your coding, and walk you through a bunch of different things. The first course that they offered for that you can find through this site is a course on R10K, Git branching, and Puppet environments, and how you can use the three of those together to deploy Puppet code really rapidly and with confidence. So that's a cool course. It's a 3-hour course that you can do from the comfort of your own couch virtually with our instructors. The Puppet Forge as well, of course, I've been hammering on this. This is a great place to go and just learn what other people have done with Puppet code. You could say, look, I'm about to take on this task of automating this thing. Maybe you want to write it to learn yourself. You can still go and find a module for that and see how other people have solved the same problem with Puppet code, where you could use that off the shelf. Or you could use it off the shelf and find it doesn't do exactly what you want, so you make a patch and offer it back to that community member. I mentioned the training stuff earlier. Again, we have a bunch of on-site courses as well as the virtual online stuff. The fundamentals course is if you leave here and you're just getting started with Puppet and you need a quick level up, after 3 days you'll be able to go and write your own content and start automating infrastructure and more. It's kind of a real quick bootstrap. And then of course there's our documentation. It's gotten a lot better over the years. We have a full docs team now that works on this stuff every day, and I've lost track of all the stuff that they're adding here. So anything from guided tutorials to reference documentation you can find on docs.puppelabs.com. You may have noticed my sticker for the Puppet test pilots. This is run from our user research team. Has anybody done Puppet test pilots in here before? Okay, Brandon, you have? It's one of my favorite things at Puppet Labs. This is a way where you can sign up, there's no marketing, there's no sales, it's just, we send out a blast saying, okay, we're working on, maybe it was for Puppet 4, we're working on new language enhancements and we'd like your feedback on doing iteration. And you could say, yes, that sounds like my game, I'd like to do that. and we'll do a video call with you where we'll run you through whether it's you actually getting hands-on with a prototype fork of Puppet, or whether we're just walking you through an exercise and you're giving us feedback. It's a really visceral way to impact the future of projects at Puppet Labs, and you get to interact with us, and t-shirts and gifts and all the hugs you can get. There's some other things too. We actually have way more to cover in slides now. Ask.puppetlabs.com is sort of a Stack Exchange style site where you can ask and answer questions about all things Puppet. We also have a bunch of mailing lists on Google Groups. We have the Puppet users list, which has 7,000 plus members on it. You can post any kind of question there and get a response pretty quickly. If you want real-time help, we still, I think, have one of the top 5 IRC channels on Freenode, Pound Puppet. And we also have Pound Puppet Dev if you're more on the code hacking side for Puppet itself. Contribute code to Puppet and all the open source projects. Please contribute to modules. You can learn about all these things and more at puppetlabs.com/community. And if you really want to go all in and work with Puppet Labs on some of these things, we're always seem to be hiring, and there's a wide range of things from all different functions in the company. I think that's puppetlabs.com/jobs. Okay, and finally, I've been at every one of the Puppet Confs, from the first one in Portland to the following couple in San Francisco, and I'm really excited that this year in October we're bringing it back home. We're going to be in Portland, Oregon for a very special conference. This is going to be a very big year for PuppyConf. I hope you can make it. It's not that far. It's like an hour-and-a-half flight. It's rather pleasant. Portland, Oregon is pretty awesome. Has anybody been? Okay, hopefully you can attest to it and not talk people out of it. But come and join us, and if you do it now, the tickets are 35% off. So I think I have 3 minutes for questions if anybody has one. Okay.
So you talked about the faster performance for the Java-based service as far as responding faster. Does that also translate to higher capacity? In terms of nodes
The number of nodes? Yeah, let me get back to the mic here.
simultaneously?
So the question was about the Puppet server, and it was able to perform faster, but what does that mean for capacity? So I guess to answer that, I'd have to say a little bit about how Puppet's able to scale, and that's largely about compiling catalogs and giving them back to the agents. So really where the Puppet master falls over, in most cases anyway, there's a lot of factors that impact the Puppet master, so I'm generalizing a bit, but you have so many agents checking in, and they're waiting for that catalog to be compiled. That's usually a CPU-bound process. You're getting that catalog back, the agent does its thing, and then it sends back a report. But really, it's that catalog step that has the most time spent on the server. So just by the sheer fact of being able to do more of those faster, we're able to reduce the amount of time we spend with any given client. And so I don't have the hard numbers in front of me, but I think that was at least 30% more agents were able to connect at the same time and not drop out because of timeouts. The question was whether it's a pool-based system, and it sort of is. So by default, Puppet agents check in every 30 minutes, and you can pretty easily set what's called a splay, where you have each agent randomize that by some variable. It might be like 30 minutes plus or minus a minute or something like that. And that gives you really easily a distribution where you might have so many of your infrastructure checking in at once. But that mcollective piece that's in there by default in Puppet Enterprise, or you can put together alongside Puppet in open source, gives you the push side, where you can reach out to all those agents. And it could be all of them, or it could be so many of them that match a criteria that you care about. And you can tell all of them to run Puppet at that time. So by default, it's a pull-based model, but there's a really easy way to go to a push-based if you prefer. Anyone else? Okay, in the back.
What's the current status of Razor?
So the question was, what's the status of Razor? And I'm smiling at David, who's been working on Razor quite a bit, but I think I can answer that it's finally moving on its way out. It won't, I think it might be, is it in the next version?
Yeah, it will be in the next version.
Okay. So the answer was it's going to be GA the next version. I know that the open source Razor right now, you could bring that off the shelf and have great success with it. A ton of work has gone into getting it on the pipeline to get into Puppet Enterprise. So at this point, it's a packaging and acceptance exercise. The code's ready, but it will be there, and it's kind of awesome.
So regarding the Razor, the bare metal provisioning, we still need the PC boot, right?
Yes, the question was, for Razor, do you need Pixie boot? And it's based on that. It's based on having Pixie and TFTP to get that microkernel on that hardware, and that microkernel communicates back with the Razor server to tell it what kind of hardware is available. And at that point,
Okay, well, we learned something about these microphones.
so
good.
these mics don't like Razor, but I hope you do. Wow, that had a real parallax effect for me. I can't really hear right now.
I'm really sorry.
Okay, let me get back to it. So to answer that question, which I now forget, can you repeat it for me? I'm sorry. You do need a PXE server, and it uses that to get hardware information. But then once Razor has established a handoff with that machine, you can move that. You can use Puppet basically to move that machine to a different network. And it's commonly what people do is they'll have a provisioning network with that infrastructure set up. They use that just to get the raw hardware into the Puppet system, and then Puppet can interact with network devices to move it to a different VLAN, for instance.
I'm too scared to turn my mic on, but you have one last question back there.
Hey, do you know some of the differences that are going to exist between the open source version of Razor and their enterprise version?
That's a good question. I actually don't. David, could you speak to that?
It's mostly a packaging installation type thing that, you have an enterprise, it's not easy to install it. Feature-wise, there's not much difference.
Okay. If anybody didn't hear that, the question was, what's the difference between the open source and commercial version of Razor? And as I guess I expected there, the answer is largely about its packaging and installation. Puppet Enterprise will, of course, do that for you by default. You have to put together your install on the open source side. In the future, we might build some workflows around Razor in the commercial side, but as I expect, the open source side won't change that much.
Perfect.
All right. Thank you so much.
Thanks, Brian.